This one was one that I wanted to talk about because of the way the table was. If I am going to go right to the chi-square test, then I am going to have to type in these observed values for females 16, 185, 297, and these observed values for males 11, 156, 299. And then I'd have to put in the expected column for females 13.97, 176, 307.89, etc. This is one that it's easier to use the contingency table than to type in all these values. So if I open this in StatCrunch, you'll notice how it goes. It's not put in as observed versus expected. I'm only given all those observed values. I'm given the happiness characteristics, and I'm given male or female. So if I go to Stat Tables, and I go to Contingency with Summary, and I pick those three columns that have the information in them, and var1 is my row labels because that's where male and female were, and I hit Compute, then it makes a contingency table. Just kind of repeats the table I had, puts some totals in, but it does give me the chi-square test statistic and the p-value. So I'm going to, first of all, determine that we're carrying out a test of independence because we're trying to find out whether happiness and gender are associated or not. And so we are doing a check for independence. In a check for independence, our null hypothesis is that two events are independent versus that they are not independent, meaning they are associated. And that's this choice A. My chi-square test statistic, if I go back, is 2.339. And my p-value is that 0.311. If I round to 3 decimal places, that's pretty large, 0.311, and so I'm not going to reject the null hypothesis. If I do not reject the null hypothesis, then these events are independent, and I'm going to not conclude that they're associated. Does this suggest that men tend to have different levels of happiness? Well, if they're not associated, if we can't conclude that, then there's no significant difference between men and women. And that's it. Hope that helps.